cold, endless darkness of space has always held secrets that have intrigued and driven humanity's curiosity for centuries. But while the universe's mysteries captivate both experts and amateurs alike, recent scientific discoveries have left many people restless. One revelation in particular has sent shockwaves through the scientific community: a newly discovered asteroid that might be on a direct collision course with Earth. This alarming news has kept astronomers worldwide on high alert, racing against time to calculate the true scale of this potential threat. The big question on everyone's mind is whether this asteroid could cause an event similar to the mass extinction that wiped out the dinosaurs, or even more terrifying, potentially annihilate all forms of life on Earth. In today's video, Moai Curioso will dive deep into what we know about this asteroid, how likely it is to hit us in the coming years, and whether it has the power to bring about the end of times, at least as we know them. Don't forget to like the video, subscribe to the channel, and hit the bell icon to stay updated on our latest content. Before everything changes, let's explore this together. How many asteroids have collided with Earth? Our planet is constantly bombarded by rocks from space, and this happens much more often than most people realize. But since life isn't a Hollywood movie, we usually don't notice when it happens. In fact, some of these space rocks might be heading straight toward us right now as you watch this video. It's estimated that an astonishing 25 million space fragments enter Earth's atmosphere every single day. According to NASA, about 44 tons of meteorite material falls onto our planet within a 24-hour period. Fortunately, most of this debris is incinerated before it even reaches the ground, turning into dust and disappearing in the upper atmosphere. This cosmic debris comes from a chaotic set of planetary objects that orbit the Sun, creating what could be described as a space traffic jam, which occasionally results in, well, let's call them accidents. Among these objects, there are three main types: asteroids, comets, and meteoroids. Asteroids are relatively small rocky bodies that, when viewed through a telescope, look like tiny bright dots. The majority of them are located in an area between Mars and Jupiter, known as the asteroid belt. Some of these asteroids are round, while others are elongated, and some even have their own satellites orbiting them. On the other hand, comets are distinct from asteroids because they are primarily composed of ice and cosmic dust. When a comet approaches the Sun, it heats up and starts to evaporate, producing the characteristic glowing tail. If you've ever observed one through a telescope, you've seen what appears to be a diffuse object with a long tail. And then there's the meteoroid. Before it becomes a meteor, it's a meteoroid, which is essentially a fragment of an asteroid or a comet. These meteoroids usually originate from collisions between asteroids, comets, satellites, or even planets. Most of the time, it's these meteoroids that end up crossing Earth's path. They can vary greatly in size, from tiny specks of rock or metal just 100 micrometers across, the width of about 1/10 of a millimeter, to objects up to 10 meters wide. When a meteoroid enters a planet's atmosphere, it changes in form and name. As it crosses the boundary between space and the exosphere, it accelerates to incredible speeds, often exceeding 48,000 kilometers per hour. This rapid movement causes it to generate intense friction with the gases in the atmosphere, heating it to such high temperatures that it ignites. The result is a brilliant ball of fire, with temperatures potentially soaring over 1,000 degrees C. This phenomenon is what we call a meteor, or more commonly, a shooting star. It's so common and easy to spot that you've probably seen one yourself. Let me know in the comments if you've ever witnessed this. The few meteoroids that survive their fiery descent and make it to Earth's surface without disintegrating entirely are known as meteorites. To sum it up, these three terms refer to different stages of the same object, depending on where it is. Meteoroids are in the sky, meteors are seen as streaks of light in the atmosphere, and meteorites are those that actually hit the ground. Meteorites, by the way, often end up being no bigger than a person's fist, less than 5% of their original size when they were still out in space. But of course, there are always exceptions, and some meteorites can be much larger than that. The fall of the last major meteorite, recorded by mankind. This event took place not too long ago, on the morning of February 15, 2013, at exactly 9:20 a.m. Residents of Chelyabinsk, a city in Russia, became witnesses to a meteor's descent that was impossible to overlook, and in fact, it would capture the attention of the entire world. The dramatic fall was caught on video, like this one from a car dashboard camera. The footage shows a bright streak crossing the sky, growing larger and brighter until it creates a flash that could outshine the sun, followed by an explosive burst before vanishing beyond the horizon. According to NASA's reports, this meteoroid, before entering Earth's atmosphere, measured 20 meters in diameter and weighed about 14,000 tons. The agency further explained that the object exploded approximately 30 kilometers above the Earth's surface. Despite this considerable distance, the effects on the ground were anything but subtle. Actually, they were downright terrifying. The explosion released an energy equivalent to 440,000 tons of TNT, which is about 30 times more powerful than the atomic bomb dropped on Hiroshima in 1945 during the final stages of World War II. Fortunately, the explosion occurred high enough in the atmosphere that much of this energy was absorbed before it reached the ground. However, even at this height, the shockwave was still intense, and the impact was felt on Earth in ways that were hard to ignore. The sound of the meteor's collapse caused a shockwave powerful enough to damage an area of over 500,000 square kilometers, affecting 6 cities across the region. The financial toll exceeded 1 million rubles as thousands of buildings suffered structural damage, and over 1,600 people were injured, many by flying glass from shattered windows. The largest fragment from the meteor, found in the area following the explosion, was discovered in Lake Chebarkul. This alien rock fragment measured about 1.5 meters across. When scientists attempted to weigh it, the scale initially registered at 570 kilograms before it broke under the weight. This artifact, while fascinating to science enthusiasts, also serves as a stark reminder of our vulnerability to the unpredictable threats from space. Authorities later stated that if the meteor's explosion had occurred at a slightly lower altitude, or worse, if it had hit the ground directly, the damage could have been far worse. It could have potentially caused an impact more catastrophic than any in recorded human history. What size of asteroid poses a threat to life on Earth? For an asteroid to have the potential to cause destruction on a scale that endangers life on Earth, it must meet a combination of specific criteria. The 4 most important factors to consider are the following. The first factor is the entry angle into Earth's atmosphere. This plays a critical role in determining the impact's severity. If the meteoroid enters the atmosphere at a shallow or more horizontal angle, its journey will be much longer, allowing it to slow down before hitting the ground. In simpler terms, this means that the meteor will have more time to lose velocity as it travels through the atmosphere, which reduces the overall energy it has when it reaches Earth. On the other hand, a meteoroid that approaches the planet in a more direct, perpendicular path will hit the surface much faster, transferring more energy at once and causing a greater impact. Planetary scientist Garrett Collins from Imperial College London explains that objects entering at a near 90-degree angle concentrate their energy over a smaller area of the atmosphere, which means they will likely transfer more of that energy closer to the surface, creating a stronger shockwave. The closer to the ground this energy is released, the more destructive the impact becomes. The second factor to consider is the location where the meteoroid will land. Fortunately for us, statistically, most space rocks tend to land in oceans or in remote, uninhabited areas. Even with the global population surpassing 8 billion people, a large portion of Earth's land still remains sparsely populated, which significantly reduces the chances of a major impact affecting human life. In the case of a collision with the ocean, the immense body of water would likely absorb the impact of rocks over 100 meters in diameter, as long as they fell far enough from the coastline. While the impact would generate massive waves, tsunamis, their power would likely dissipate as they spread across the ocean, weakening significantly before reaching coastal areas. The third key factor is the speed of the meteoroid. The velocity at which the object is traveling through space greatly affects the severity of its impact. Meteoroids can enter Earth's atmosphere at speeds ranging from 11 to 40 kilometers per second. The faster the object, the more energy it carries, and with more energy comes a greater potential for destruction. This variation in speed means that some meteoroids could cause relatively mild damage, while others, moving at higher velocities, could lead to catastrophic consequences. But no factor is more important than the size of the object. When it comes to potential destruction, no aspect is more critical than the size of the object. The larger the meteoroid, the higher the chance that it will break through the atmospheric barrier. However, size alone isn't enough. The mass is also crucial, which is calculated by multiplying the volume by the rock's density. This is because the denser the object, the higher the likelihood that it will survive its journey through the atmosphere and reach the surface without completely disintegrating. While it's rare for a meteoroid to meet the ideal conditions in these 4 key areas, the same can't be said for an asteroid. While meteoroids like the one that fell in 2013 have mostly localized effects, an asteroid can bring much more devastating consequences. But what if a smaller asteroid were to collide with Earth? According to NASA, a meteoroid the size of a car impacts Earth approximately once every year. On the other hand, an asteroid the size of a football field strikes our planet only once every 2,000 years. But what would happen if one of these asteroids were to hit us right now? We can get a sense of the potential damage by looking at a recent historical event, the largest asteroid impact ever recorded in modern history. On June 30th, 1908, an asteroid measuring 50 to 60 meters in diameter entered Earth's atmosphere and exploded over Tunguska, a remote area in Siberia. While the impact didn't cause mass casualties due to the sparsely populated region, the devastation was nonetheless staggering. The few witnesses who were around 30 kilometers from the blast described seeing massive forest fires and trees ripped from the ground, hurled for miles. Those closest to the explosion reported being thrown into the air by the force of the blast, losing consciousness from the shockwave. Many homes in the area were either severely damaged or completely destroyed. It wasn't until nearly 20 years later, in 1927, that studies of the site were initiated. Even nearly 2 decades after the event, the landscape still showed unmistakable signs of the catastrophic explosion. The Russian scientist who led the expeditions to Tunguska described the destruction as resembling the shape of a butterfly, covering an area of 2,150 square kilometers and taking down an estimated 80 million trees. Something similar could very well happen again in the near future, and the next time the consequences may be far more severe. 2024 YR4. Scientists have recently identified an asteroid that was once a mystery, but has since emerged as a real threat with potentially catastrophic consequences for our planet. On December 27, 2024, astronomers discovered a new asteroid, which was initially named 2024 YR4. From that moment on, it quickly gained significant attention, but for reasons far from noble. Quite the opposite, in fact. The asteroid was now on track to become a growing concern, as it showed an increasing chance of colliding with Earth in 2032. Just days after its discovery, the situation became even more alarming, with scientists calculating a 1% chance of collision. This made 2024 YR4 the first major asteroid known to have such a high probability of hitting our planet. As researchers began to analyze the collected space data in more detail, the chances of impact continued to rise. By January, the probability had increased to 1.2%, and just a month later, it had nearly tripled. By February, the odds had reached an astounding 3.1%. While this percentage might seem small to some, for experts in the field, it was headline news. After all, it represented the highest likelihood ever recorded by NASA for such a large object. The asteroid's exact size remains uncertain, but according to NASA, it is estimated to be between 40 and 90 meters in diameter. While it may not be large enough to cause a mass extinction event like the one that wiped out the dinosaurs, it was still big enough to earn the terrifying nickname City Killer, given its potential to obliterate a major city. Initial calculations on its trajectory suggested that 2024 YR4 could crash or explode over massive urban areas, including Mumbai in India or lakes in Nigeria, regions that are home to millions of people. However, just a day after the initial 1% prediction, the chances of a collision began to dramatically decrease. By February 19th, the probability dropped to 1.5%, and the very next day, it plummeted to 0.3%. A few days later, NASA posted on social media that everything was clear, indicating that the likelihood had almost evaporated, much like a small meteor burning up in Earth's atmosphere. From 0.3%, the chances shrank to just 0.004%, or 1 in 25,000. A few days after that, the odds were further reduced to 1 in 59,000. This rapid decrease in probability was due to researchers gathering more data from telescopes, which helped them refine their understanding of the asteroid's orbit around the Sun. The more data they collected, the more they were able to pinpoint the asteroid's trajectory with certainty, ultimately concluding that Earth was no longer at risk. While the Earth may now be statistically safe from destruction by this unwanted visitor, NASA still notes a small chance, less than 2%, that 2024 YR4 might strike the Moon, potentially adding another crater to its surface. So, does this make you feel more at ease? Or are you still not entirely convinced that we've truly dodged a bullet? What about other collisions you've heard of? Can you think of any that I haven't mentioned here? Let us know in the comments. As long as life continues on Earth, Moai Curioso will be here to bring you the most astonishing stories you've ever heard. And if you're not already part of our community, be sure to subscribe to our channel to support our work and help us deliver even more high-quality content. Don't forget to click the bell icon so you never miss a video, and of course, leave a like on this one. Until next time.